Fundamentals, node fundamentals. Continuing on, we're going to talk about events and event emitter. So, event emitting is pretty important concept in Node.js. As we talked about a long time ago, that asynchronous event-driven architecture that the Node core is based on, that whole thing. Again, the creator of Node.js, Ryan Dahl, when he thought about this, how could we take that rich client-side event-driven kind of behavior and look at the server in a different way and apply it to the server level. And at that point in time, it was very big departure from how they were doing things. So this is very important, understanding how event emitters work and how you can emit events versus just regular events. So the emitter object will periodically emit events that will cause listener objects to be called. So there's going to be a bunch of listeners that you can set up that may be waiting to be triggered, right? So once you trigger it by emitting something, uh, basically however many listeners may have subscribed to that, you can trigger a whole bunch of things. Like maybe some process has run. When it finishes, it's going to trigger or emit that it's finished, and somewhere along the line there's a listener that picks that up and kickstarts another backend process. Maybe it goes and clears out all the log files. Maybe it does some other type of big computation. Whatever it is, there usually will be a callback function attached to it, so that when the listener finally gets is finished and it triggers, then the callback function will then be executed. And again, the internal architecture of Node.js, there's a whole concept of event loop, and this ties into event loop. So event emitting, and how events are emitted and how they can be all attached to that specific event, and they're all called synchronously. But the way Node.js will handle things in a non-blocking way is it will take that callback function and put it on the stack, and basically whenever it needs to deal with it, it'll then process it at a later time. But we'll get into the internal workings and all of that in libuv and the event loop, which Node is famous for. But understanding the concept of event emitting is very key, and a very key concept to the fundamentals. So event emitter, that's what that is, based on what an event is. So event is something that happened in our application that we can respond to. So some event has happened, and then we're going to basically respond to that event, as opposed to triggering our own events that can be handled to all of the subscribed listeners in various ways. So there's two different types of events in Node. So there's system events, which happen within C++ core libuv, like say a socket has opened, a socket has closed. When we're talking about TCP/IP connections and socket I/O, or a file has read and a file has been deleted, or a stream has opened and a stream is closed. These are events, right? And you can have emitters and triggers based on all those events that occur. Custom events are those JavaScript core events, the event emitting thing, the custom events that we create in our code, and then we can trigger them based on our emitters. So events in the DOM. So this is where it all came from, right? This is where the concept of the whole Node.js event-driven architecture came from, is because we were so used to the UI being very rich with event and very, very driven. So the DOM, which is the document object model, triggers events that you can listen to, and you can subscribe to those in the same way we're talking about. So in the web page, you have various controls. When you load up, so one event would be you load. The page loads up, the window loads up. In jQuery, the window is ready, and inside of that, you have all of the different controls, drop downs, you have text boxes, you have button clicks, you have all this stuff all these controls that have events attached to them. And there's listeners attached to those, right? So if you walk up and you click a button, well, something can respond to that. Maybe a form is submitted. Maybe when you click something, you toggle a panel, hide show. When you submit a form, that's an event. when you hover over something, that is another UI kind of event, right? You hover over something, it triggers something else, some visual representation. So basically, this is kind of a way, in the same sense of mimicking that. Like when you click in this example here, you have a paragraph using jQuery, that's the $sign, and you've wired up you wire up a listener, say when this is clicked, I'm going to go and I'm going to execute a function and whatever it does. So we take the same concept here and we apply it to the server level with our emitters, right? We're trying to mimic the UI to make a server very responsive and very asynchronous, non-blocking, to be able to handle multiple things in a very, very fast way, high performant way. So basically node emits events as we talked about. So here's an example here. We have the net server class inherits from event emitter. So a lot of these classes will have event emitter as a base class, and they all can tie into emitting the different request events. So also file stream. So file stream is another one we'll learn. File stream is, has all different types of emitters on it. Like you can emit when the stream has completed or when the stream is opened, when the stream is waiting. So in this example here, if a user reading a file calls a file fs read stream, then it returns a stream that inherits from the event emitter, and it will emit data event as the user is reading the data out of the file. So basically, a lot of the built-in functionality has event emitter as a base class somewhere in its inheritance, its hierarchy, because again, it's event-driven architecture, and we want to take advantage of that. We don't necessarily want to do things in a synchronous way. There may be times you may want to do that, but for example, if you're reading from the database, you want to do it in an asynchronous way, especially if it's a very long read or query. You don't want to be tying up resources and other processes from that would have to wait for that to finish. You want to offload that and defer it until that read is done, and then when it's done, come back in and trigger that it's done in any listener, an event that may be triggered off of that. Custom events. So this custom event emitters, we can create our own custom emitters as long as we use the emitter constructor. So here is how we wire it up. We require emitters and we do dot emitters, so we have that object. And then when we want to set up our own custom emitter, so we had logger, we need to instantiate that new object. This is a pattern you need to know because you're going to be using it a lot. So you need to new it up. New it up means you say new object, new event emitter, it's a new object, and then we have on that, we have those dot on and dot emit that we need to use. So here we're wiring up that logger.on error. So what that's saying is when I'm setting up a listener on this string, name string it's called a name string error, and then here's my callback function, and all it's going to do is console log the error message to the console. If we want to go and trigger something, we go logger.emit, and we're using that name string that's registered error, and we're sending it the message of egg is cracked, and it's going to output that in the command line. And then we're going to go through and emit the same error but with a different message. So we're going to say spilt milk. So basically that is how we would wire up a custom event. So we can look at this, we can look at event emitting in this way. Just a representation is that we have this emitter that emits events, and sometimes it will pass data associated to it. Not always, but it'll send data in the pipeline. And then we have the event that happens, right? So when that event happens, it triggers an emitter, and then you may have a bunch of listeners. And some listeners may do nothing, but then there may be a listener that'll execute some action based on when that event is emitted. So that's a visual representation of what's happening. And again, just recapping how you create this because it's important. First, you want to use that events module. You want to require it. That's it. You want to set a variable to events, and then you want to new it up. You want to use inside of that event. There is the event emitter object, so we need to create a new instance of that event emitter object, and then we set that to our own local variable, and now we can start to use it. So number 3, we create a callback function for the event. So we say emitter.on, and then we give it a name string. We register that data underscore received. We're going to listen for that, and then we have a callback function which is console log. Later on, we trigger the event emitter.emit, data received, then it will go through. The listener will then catch on to that broadcast, that emitted event, and then it'll execute whatever callback function that it has. Another example here, just a little bigger one. This will, on the right side, you'll see the console log of what will happen, and then on the left you'll see this code example. So it's a little bigger. So you're going up and you're requiring event emitter, and then you are basically inside of that. That's actually a strange way, but I guess that's okay. Inside of the function, you could have done it outside, but they're putting the emitter in this local scope. So you have a function loop game. We're creating that emitter E, and then we're just setting a timeout with a function that is iterating over the number of times. So if somebody passed in 5, it's going to go through. It's going to iterate. It's going to say before game. It's going to emit the before game, which will go and trigger a callback. It's going to console log the game show, and then it's going to emit after game. And it's going to set a timeout for 2 seconds. So basically, if we look at that, we have the loop game starting with 3. So it's initializing 3, and then we're registering our callback function. So we say on before game, it's going to say console log about to start, and then after game, we're registering this again. The game stop. So basically, that's just a way of. Now it doesn't really matter. You could set up register your listeners a little bit earlier than the function. Here we're doing it later. That doesn't really matter where you put them. It's how you design your code. So we're going to look at an example here. I'm just going to pull it up. All right, so we would like to build a kind of tick-tock clock. So we would like to, when we run node clock.js, we'll start in the start section, but we would like this kind of tick-tock kind of thing going on here. But if we look at the code file we have right now, we just have a function, arrow function tick that just console logs tick. We have a talk function that console logs talk, and we call it, basically when we call node.start.js, all we're going to get is tick, right? There's not much interaction there. So what we need to do is we need to walk up and we need to instantiate that event emitter. So we're going to do this event require equals events. Sorry, my mistake here. We can either do const or var, whichever we want. So maybe I'll do const. I'll say events equal require, and we want events, right? Events. For the sake of coding, I always get this one. To be honest, I always get the syntax wrong because I don't use that. And I'll do quickly. I always forget to new it up correctly and use this dot event emitter. I always forget that. I always have to look that up because, you would expect it to be there, but because if it's an object, you can't necessarily use it destructuring because you need to new it up in this way so you can actually be extremely specific about what you're using it for. So here we have emitter. So now we have the emitter, and we can actually do a custom event here. So what we'd want to do first is we probably want to get some interaction going on. So we would say we already have these functions already defined. So we would want to, so we could treat them as the callback function. So what we would do is we would say emitter dot on. So we're going to say tick. We're going to call that tick, and we're going to go through and we're going to execute that function. Now you may just call it by reference, and again we're going to do emitter dot on dot talk, and we're going to pass that function there, right? So if we were to go through and we were just to get rid of this function call, and we would just say emitter dot tick, like that, just to trigger one of them. So therefore we've set these up, but because I'm triggering, emitter dot tick, we are going to, my mistake here. You can't just call it like that. You have to actually use emitter dot emit. It's live coding right here. At least I can pause and resume when I get it wrong. You can't do that when you're doing it live. So emitter.emit tick, right? So we are going to trigger this. We're going to emit this, and when it catches the listener setup, it's going to call this method here. Now I can call it something else. I could just call it, if it's for argument's sake, you know, it may be a little confusing. You could rename it, say display, tick display, or console log. We could just walk up and just call it this, just for argument's sake, so it's not too confusing. We'll just say tick log, meaning log to the console, talk log, and the callback function is talk log, so it's a little bit more clear what we're calling when we trigger this emit. So let's see what it does. So it called tick, that's all it did. So it actually went from here up to this listener, triggered back up here. So that's not exactly a very good clock. It's not giving us what we want. So what we would do is we could actually use one of those timers that we were talking about before. So JavaScript has set timer and set interval, set timeout, which would execute something on a timeout. And in the other example I showed on the slide, it was doing a for loop over a timeout. We don't need to do that. We can actually use something called set interval. Set interval will execute it every interval that you set. So set interval, it kind of gives us a little bit of a markup here. So the interval is actually the number we want. So we could set it to, say, 2 seconds, 2000 milliseconds. And inside of this, we're going to call, what are we going to do here? We can emit tick like this, in this way. So on every 2 seconds, it's going to emit the call to tick, and then hope some listener will pick it up. So what we got here is it's just going to start ticking, tick, 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 which is great. But we want that other function to also call. So we can do a couple things here. We can do something. As create another interval that would happen right after it, which is fine. But you just have to make sure that the seconds match up in terms of there's enough delay that there won't be overlap, which there may be overlap after a while, but we'll run this. So we have another interval that's going to call the talk, and it's going to run on every 3 seconds. If we would run it, we may get a little bit of a mismatch kind of thing going on here. So let's see here. So it's going to go tick, talk, tick, talk. So that may work over time. The other one might start to catch up with one another. Like it might start to see there, you get 2 ticks in a row. So it's not exactly what we want. I mean, it's working in a way, but so what can we do here? So maybe we would, let's see what we would do here. So maybe instead of putting the intervals externally, maybe we would take this interval and put it internally to this, to call it internally into this function callback. So when we trigger this one, it'll go and trigger the next one, right? It'll go to this callback, and then maybe we'll trigger it back. So it basically we'll trigger one, which will trigger the other, keep triggering each other. So we'll put this inside of talk. So now we have a set interval that's going to call each other. And then what we need to do is our listeners are set up here, and we go up here and we say, let's start this thing. So we could actually say tick log. Let's try that. So when we first start it, let's see what that does. So so now it's actually so the timing's a little bit messed up, but it's actually going on interval. So one's going 2 seconds, one's going 3 seconds. So that's not going to work in the way we want it. So we have to, probably the best approach would be to, now we're getting into timers and set intervals. So this is actually getting a little bit tricky, right? What would be smart, I think, is to go back and to extract this out of both of these and have, we'll leave that one there for now. So we'll call this one from the outside. So what this is going to do is it's going to set an interval and it's going to tick. It's going to call event emitter. It's going to tick from the outside, and it's going to trigger this one, which we'll call talk. So let's see what happens there. Let's see what happens. we'll get rid of this code right now. And we are going to set interval on this. That was a little example, little preview what's going to happen. So if we run this here, tick log has already been declared. Let's see what we're happening here. Tick log has already been declared. It was already declared for some reason. So when we go and start this, so now it's actually going to work kind of how we expect it. I mean, in a way, but what's happening is it's not executing every second. It's kind of just doing tick-tock right at the same time because that makes sense, right? It's calling each other right away. So the solution to that is what we want to have a little bit of a delay inside of the talk log, right? We want the first one to be triggered, and then when it hits the second one, we want maybe a second delay before console logging talk. So it gives us a little bit of that kind of responsive ticking, right? And because it's 3000, again, we're just playing with timers here. It may be a little confusing, but it's good to know. So if we were to walk up here and just say, I think we had it already there, we want to set a timeout on there. So we want to set a timeout that we're going to console log this message, and then we're going to wait a second before we call this one again. So we got a little bit of a delay. So it's not, ideally this is how it would go. So when we do the tick, when we're executing it, it'll do talk, tick, talk. It's still jumping. It's not perfect. You could play a little bit with some of the timing, but that's what timers, and these event emitters, they get a little bit tricky, right? When you need them to work in sync. I actually had another one where I did tic-tac-toe where you're actually using 3 event emitters and getting them all to respond within a delay. It's a good test question. Just wanted to show it how you could build your own clock a little bit here and use 2 event emitters and timers. It's a good introduction to timers and intervals because we're going to get into that when we talk more about the event loop in Node Fundamentals 2.